How about some factoring? This is it. It's the grandpappy. It's the big kahuna. It's the pinnacle of our journey. It's the accumulation of all our lessons. It's the climax of our plant. Yeah, that makes sense. Look it up. What does this say? Louder, Alicia.
This is one of the most important processes of the course.
Yeah. And it has a large number of applications, that means like good stuff, in almost every math course you will meet in high school. You guys aren't in high school. Did you know that? When I went to school in Coquitlam, there was a high school. It was just 11 and 12. 1,800 kids, just grade 11 and 12. Okay? We had a junior, 8, 9, and 10. We just have one junior in this district. It's over in Brock. Okay? And it's not even 8, 9, and 10. But in a lot of places, that's quite common. Okay? This is junior. You're still a junior student. High school is 11 and 12. And or further education. Okay? So critical, critical, critical. Anyway, I don't mean to freak you out, but everything we've done, like I said, 9 times, let's make it 10. We factored these where A was 1, right? Here, A is 1, and I don't even know if this factors. I'm just throwing it out there. We've done some of these. You just do it by inspection. It's a trinomial, so you just throw down a couple sets of brackets and try to piece it together. What multiplies to -1? What adds to 3? What two numbers? They go in the brackets and you're done. Okay, this is a little more involved. So, complete the following. This we did last chapter. That's a binomial times a binomial. How do you do this? FOIL it. Okay, so 2x times 3x is 6x squared. Okay, outside 4 times 2x is 8x. Inside 1 times 3x is 3x. And last is 1 times 4 is 4. Again, you don't have to do it in that order. We just give you a little acronym so that it makes sure you get 4 terms. FOIL, 4 letters, 4 terms. Okay? So, yesterday, did you see something like that? And it said factor by grouping. Okay? You've done these. You just did them yesterday. That's why yesterday's lesson before today's makes much more sense. But if I write this as, and I collect these like in last chapter, I'll get this, right? 8 and 3 is 11x and 4. So we need to know how to factor that. Factoring, again, is the opposite of multiplying, right? Do we know how to do this? No. Because all you know to do is, well, what multiplies to 4 and what adds to 11? What two numbers, Tyrell, multiply to 4 and add to 11? But you know you have to factor it because, hey, there it is, right? We weren't telling you the full story. You actually have to say what multiplies to 6 times 4 and adds to 11. Now the reason we didn't need to know that last time was because that was a 1. And what's 4 times 1? It's just 4. Okay? So what we want to do is make it look like this. We want to factor this guy by grouping. Okay? So this thing in that form, flip on over to here, there it is. Okay? And a little review from yesterday. We want to do this by grouping. When you see those words, that means, what do you take out of the first two? What can I take out of here? I can take a 2 out of 3 and 6, and I can take an x out of x squared and x. Okay? And how many times does 2x go into 6x squared? Okay, 2 goes into 6 3 times. X goes into x squared x times. How many times? Oh, that doesn't work, does it? I can take a 3 out. That's better. How many times does 3 go into 6? Twice. How many times does 3x go into itself? Once. Okay? Then look at the next two. What can I take out of there? And remember, you see this set of brackets? If I don't get those same set of brackets, I can't do anything else. So sometimes maybe you want to start there. What do I factor out of 8x and 4 to give me this? Well, how many times does 2x go into 8x? 4. And then check your sign. Well, it's got to be a positive. Okay, so you can kind of work backwards. I know I need the same thing in both sets of brackets. Okay? And this was like the beginning of yesterday's lesson. We gave you some of those and said, factor it. What's the greatest common factor? I got a 2x plus 1 here. I got a 2x plus 1 there. Take it out. Okay, what do I have left? 3x and 4. Okay, so that's what we did yesterday. That's factoring by grouping. If you've got the 4 terms, that's what you want to do. The thing is, we don't know how to get those 4 terms. If we're given this, how do we make it 4 terms? How do we make that 11x, 3x, and 8x? Okay, how do I split this thing up so I can factor it by grouping? That's the process today. Okay, well, how do you know to do that rather than like 9x and 2x? Or maybe I can split up 11x into, what are some other choices? Yeah, 5 and 6x, 10x and 1x. How do you know what to split it up into so you can factor it by grouping? Well, we've already done this. What multiplies to 24 and adds to 11? What two numbers? There they are. You want to split up 11x into 8x and 3x. Then you can factor it by grouping. Okay, so we've already done this before with inspection. But here we just got another step first. We can't just throw it in 2 sets of brackets. Those aren't the 2 numbers. Okay, but that's what we're going to split 11x into. So then we can factor it by grouping. Okay, this is called method of decomposition. I'm not going to ask you that on a test, but sometimes it's nice to know what the heck you're doing, right? Okay, that's it. A couple of examples. Is A 1 here? When I say A, all of these are written in this form. A here is the coefficient of the x squared term. Is A 1? No, it's not. Okay, if it was, I would just do it by inspection. Okay, so I'm going to have to use this process, method of decomposition. Again, what multiplies to A times C? Maybe we want to highlight that. Okay, so I'm not just going to go what multiplies to 6. I'm going to go what multiplies to 6 times 2. That's 12. And what adds to the same middle term? Call it B if you want. There's B, right? Or just look at the middle number, 7. What two numbers multiply to 12 and add to 7? 4 and 3. Okay? So I want to split up 7x into 4x and 3x. I still have 2x squared. Okay, I still have 6. Is this thing the same as this thing? Yeah, I didn't change it. Okay, it has to be the same thing. You can't make it something different, right? 4x and 3x, that's 7x. There it is. All I did was split it up. Now I have 4 terms, and I can do it by grouping, what we did yesterday. What can I take out of 2x squared and 4x? 2x. 2x goes into 2x squared, x times. 2x goes into 4x, 2 times. Okay, factor the next 2. And if this helps, hey, do it. Put a couple sticks there. What can I take out of 3x in 6 plus 3? 3 goes into 3x, x times. 3 goes into 6, 2 times. Do I have x plus 2 in both sets of brackets? Yeah, I'd better, right? Or I can't do anything else. Take that out. What do you got left? 2x plus 3. Okay. How do I know if I did this right, Bryce? Yeah, FOIL it. Let's check it. 2x times x, is that 2x squared? Yes. 3 times x is 3x. 2 times 2x is 4x. 3x and 4x is 7x. And 2 times 3 is 6. Check. It's the same thing. It's factored. Okay? So just one little step, and then you get the stuff you got yesterday. What's the little step? What do I want to do? What multiplies to what, Tyrell? Yeah, 5 times 2. What multiplies to 10? What adds to 7? What two numbers? 5 and 2. Then what do I want to do? Mariah? Split up 7x into 5x and 2x. That's 7x, right? I still have 5x squared. I still have 2. Now what I want to do, Mac? Factor by grouping. What can I take out of the first 2? I can take out a 5. I can take out an x. What do I got left? X plus, how many times does 5x go into 5x? Once. Okay. What do I want to take out of here? A 2. Am I left with an x plus 1? It's always nice to check. Let's double check. I'm not sure. I'm kind of confused. Check it. Is this the same as this? Yes. Is this the same as this? I got 5x squared. Check. 5x times 1 is 5x. Check. 2 times x is 2x. Check. 2 times 1 is 2. This is the same as this. Okay? Check each time, each step you do, because there's nothing worse than getting to the very end, finding out it's wrong, and going, oh, darn it, got to redo the whole thing. You can check it, each step you do. Okay? What's common in this term and this term? An x plus 1. Take it out. What do you got left? 5x plus 2. Then, hey, check it again. 5x squared and 2x and 5x is 7x. Check. 1 times 2 is 2. Bingo. Okay, any questions? Just going to do a couple more, and then boom, you got tons of time to work on this, right? Where am I? Okay. Factor. What's the first step? Tessa. Yes, you do. Bailey? What do I want to do? Yep. What multiplies to 6 times, that's a minus 3, right? So minus 18. What adds to 17? 9 and 2? No. 6 and 3? No. 18 and 1? Okay. If I take the difference of those, I might end up with 17. But to multiply to a negative, one of these has to be a negative. Where do I want it? Do I want it here? No. That's going to be negative 17. 18 times negative 1 is minus 18. 18 minus 1 is 17. Make sure you check that carefully, okay? Because if you screw this up, then, you know, you got a lot of work to do to fix it, okay? Why did I do that? Colton? Why did I do that? What do I want to do next? well, yeah, I want to split up 17x into 18x minus 1x, or just minus x. Is that 17x? Yeah, that's it. Okay, I still have 6x squared. That's a plus. I still have a minus 3. Now, factor by grouping. What can I take out of this and this? I could take a 6 out of there, and I can take an x out of there. And what's 6x squared divided by 6x? Another way of thinking of it. What's 18x divided by 6x? 3. And remember, maybe you want to do it this way. If I got x plus 3, that's what I want out of here too. What kind of a sign do I need to put here? What do I factor out of these two to give me this? A negative 1. Okay, that's kind of confusing. Let's stop there. Let's check it. Is this the same as this? Yep. 18x minus 1x, 17x. 6x squared? Check. 6x times 3 is 18x? Check. Negative 1 times x is minus x? Check. Negative 1 times 3 is minus 3. This is the same as this. Got the same thing in the brackets, so I can factor that out. Take that out of both two terms. Bracket, bracket. What do I got left? 6x minus 1. She's factored. Okay? So trinomial, it factors into two binomials. By the way, you could try it by inspection, right? You could just throw down a couple sets of brackets, but you got to get 6x squared. Remember, it was just x squared, right? So it was x times x. Now, see, this is tricky. Is it 6 times 1? Or is it 3 times 2? And then that's got to be minus 3. Do I put the 3 and the 1 there? Or do I put the 1 and the 3 there? It's possible, but you might be farting around for like 20 minutes trying to piece it together. Okay? But if you get stuck, if it's a test, trying to get the mark, it can be done. Okay? But that's not the way you're supposed to do it. This is the way it's being taught, right? That's the way we do it. Okay? Did I say how important this stuff was? Okay, I better say it. Let's just put it this way. Can you pass this course without completely getting a 0 in this whole chapter? Yeah. Could you even maybe get 60% in this course? Failing this complete chapter, getting like a 0, which is pretty hard to do because like 3/4 of the test is multiple choice. But I've seen it done. Guys have really bad luck. Okay, yeah, you can. But if you're planning on taking Math 11 pre-calculus, if you don't get this and you get a good understanding of it this year, now you're lucky if you're getting 30%. Okay? That's the reality. Okay, what do? What multiplies to negative 8 times 3? That's negative 24. What adds to negative 2? Got lots of negatives this time. What two numbers? 24 times 1? No, probably not. 12 times 2? That could give me 14 or 10. So no. 8 times 3? That could give me 11 or 5. Nope. 6 times 4? That kind of looks like a 2. Okay. 6 times 4. Where do I want the negative? On the bigger one. Okay. Double check it. Negative 6 times 4 is negative 24. Negative 6 plus 4 is negative 2. That's what I want to split up minus 2n into. Minus 6n plus 4n, is that minus 2n? Yes, it is. Okay, I still have minus 8. Bring down the 3n squared. Factor by grouping. Take out a 3n, you got n minus 2. Take out a 4, and you have n minus 2. Hey, I got the same thing in the brackets. What a coincidence. Take out the thing in the brackets. What do you got left? Okay. You get pretty good at these. You know, you can do them that quick. Should be an easy mark. All right. How many more do we need? Now, let's skip that guy. This one's a little different. Tell me why it's different, Bryce. No, it's not. 15's positive. Well, they got the squared term last instead of first. Do we care? Maybe not. But if it bothers you, is there anything that says you may not write it in this form? Does it say that? No, it doesn't. Then do it. Okay? What multiplies to negative 2 times 15? That's negative 30. What adds to negative 7? Those are in descending powers of y, right? That's how we kind of want it. Everyone understand that? Descending powers of x. X squared, x to the 1, x to the 0. Right? Remember that lesson about a month and a half ago? Put things in descending powers. Okay? Just to be consistent. What times this and this? Yeah, that's 10 times 3. It's 30 times 1. It's 6 times 5. Nobody ever wants to look at the 10 and the 3. That's negative, so that's got to be on the bigger one. What's my next step, Emily? Put it in? Yeah, put it in. Let's put it in. The negative 7y is the same thing as minus 10y and 3y. Still have minus 2y squared. Still have 15. 4 terms. Factor by grouping. What do I want to take out of here and here? You got a choice. Do I want to take the negative out or just a positive? You know what? I don't know yet. Let's try the negative 2y. Okay? What am I left with? Positive y. Stop right there and double check it. Negative 2y times y, that's minus 2y squared. Okay, I got it right. If I take a minus 2y out of a negative 10y, that's got to be plus 5. Okay, check it. Negative 2 times 5 is negative 10, and I have a y. Looks like I was right. What do I want to take out of here to give me a y plus 5? A 3 will work. Okay, so if you just took out a positive, then you would see these signs wouldn't work. You wouldn't get the same thing in the brackets. Just rethink it. How can I make that? Remember the little trick? Maybe you'd want to take out a minus out of here to make it work. That could work too. Okay, y plus 5 minus 2y plus 3. That's the answer. But if you looked in the back of the book, they wouldn't write it like this, would they? They would write it like this. 3 minus 2y. Is that the same thing? Yeah, for sure. Okay. K's. Oh no. He hasn't done one with K's before. This one's a little different. We haven't seen one like this. Do you know why yet? What multiplies to negative 10 times 15? What adds to 5? Do you want to find those two numbers, Adam? Come on, quick. What multiplies to negative 150 and adds to 5? Tyrell. What multiplies to negative 150 adds to 5? Colton, you got it? Okay, do we want to do something else first? Look. Does anyone see one of these? Guys, I don't know what this is, okay? I'm not just picking on you. I don't know. I would have to work it out. Might take me about 5 or 6 seconds. What do we want to do first? Is there something common in all 3 terms? Yeah. Do it. Make your life easier. Take a 5 out. Because you'd much rather go what multiplies to negative 2 times 1 and what adds to 1 than 150. Hey, can I do that by inspection? Is A 1 now? Do this. Let's put that 5 way over there with the bracket. What would you do if you saw that? Hey, piece of cake. What multiplies to that and adds to that? Well, 2 and negative 1. k plus 2, k minus 1. Let's bring the 5 back, okay? Don't forget, by inspection, if this thing isn't a number other than 1, why bother going through the whole process, okay? It'll still work, but don't forget what you did like 3 days ago, okay? Multiply that out, check it, same deal, yep. Okay? Sorry? 3k squared. Oh, here. Oh, darn it. Well, let's backtrack a bit. That doesn't work. Okay. 3k squared. I can't do that by inspection. All right, but I still would want to do this. What multiplies to negative 6 and adds to 1? 3 and minus 2. Okay, so we're going to split up 1k into 3k minus 2k. I still have minus 2. Okay. Okay. I still have 3k squared. Okay. Okay. That 5's still there. If that helps visually, just get it out there somewhere, okay? It's all times by 5, but you don't need to cram it right in here and get all confused and go, Mr. Watson, okay? Factor this by grouping. Don't worry about the 5. Just look here. What can I take out of 3k squared and 3k? 3k, k plus 1. What can I take out of here? A 2, but let's make it a minus so that this becomes a k plus 1. Okay, let's check it. Let's check it. Don't worry about the 5. 3k squared, check. 3k times 1 is 3k, check. Minus 2 times k is minus 2k, yep. Minus 2 times 1 is minus 2. This is the same as this. This is the same as this. This is the same as this. Okay, so far so good. Then take out k plus 1 is common to both things. What do you got left? 3k minus 2. What am I forgetting? Bring the 5 back. Yeah. Now let's tuck him in here. There it is. All right, thanks, Colton. I screwed up there. All right. That should be enough. Practice, practice, practice. Let's just skip those algebra tiles. Let's get right into this. 9AB, and then, why do I have 5 last? You remember that nice area question I did yesterday? The one from the day before? Yeah, that's one of those, okay? Important, if you want an A, know how to do it. Can we still get like a B without doing it? Sure. Okay. Sorry? Yeah. Yep, you need the practice. Well, 10 and 11 is just multiple choice ones. Those are the important ones, right? But yeah, 4, do all the 4. You need it. Okay, this will not be on the quiz tomorrow. The factoring by grouping, yesterday's will be. Okay? And that's basically it, guys. Our test is going to be Friday. We're going to do more practice with this tomorrow. Okay, a little quiz, some more practice test Thursday. Okay, lots of time to still learn it if your head's spinning.